Hello, everyone. I have about 30 minutes of prepared notes and remarks, and after that, it's mostly based on whatever question you ask me, so feel free to ask questions at any time. The topic of this conversation is building document-based system, and this is mostly the case because I've been building relational-based system for the last 10 plus years, maybe more. I remember building access-based system in high school and actually being very impressed by what I can do with them. And then I actually learned that everything that I've done in high school and in like 5 years of actually working with software in a real capacity were mostly building very elegant ways of producing crap software. Okay, in terms of what sort of code base, in terms of working, in terms of how easy it was to maintain. And the really interesting piece is that one of the reasons that there is so much bad code out here is that all of this bad code actually pays for itself. It doesn't actually take a lot of work to produce a viable solution. And so I've been doing that for a while, and then I started thinking, okay, how can I choose elegance? I've been looking at other stuff such as the NoSQL systems. I've been building NoSQL solution for a while, but what I want to talk about right now is actually the design approach for building non-relational systems, specifically document-based systems. So designing a system, architecting a system is mainly an issue of how you actually addressing the limitation that are placed on you by the system, the requirement, the deployment scenarios, the non-functional requirements, all of that, and what sort of team you have, all of those interesting issues. Most people are coming to this webinar probably in the interest of NoSQL performance, scale out and stuff like that. This isn't what I'm going to talk about. NoSQL solutions have the properties that makes them very scalable, but what I'm more interested in is the way that you design system using them. So the first thing that we need to talk about is what sort of models, what sort of building blocks do I have with a model with a document-based system? And usually when we think about a relational system, or when you basically think about any classically designed system, we're going to have something like a database, which is the master store for everything. We're going to have some sort of a business logic layer, and we're going to have some sort of presentation layer. With the document-based system, we don't really think about our system in such monolithic terms. Usually, I like to think about my systems in terms of functionality, in terms of what sort of pieces do what. And it turns out that such a system lends itself very well to domain-driven design, to CQRS. It lends itself very well to the way most document database work. So let's talk about something very simple. The idea of a root aggregate. So in domain-driven design, we have the idea of a root aggregate, and a root aggregate is the main entry point for making any sort of changes to a persistent model. And I'm being very careful with my terminology here. What do I mean by the main entry point? Let's take an example of a root aggregate in the traditional blog model. So the blog model that we have is, we have comments, and we have posts, and we have blogs, and we have users and tags and stuff like that. Those are all stuff that we generally use. But when you're talking about root aggregates, we probably have 3, maybe 4. So we have the aggregate, which is user, we have the aggregate, which is blog, and we have the aggregate, which is post. Maybe we have an aggregate called comments that depend on a lot of other stuff. An aggregate, so when I'm talking about an aggregate, let's talk about the post. So any change to the post and any change of a child of post has to go to a post. And this is very easy to think about when you think about what is the transactional boundary. So if I want to change a comment, to add a comment, to mark a comment as spam or something like that on a blog post, I have to go to that post. If I'm doing that in a relational system, the transactional boundary is the row. If I'm doing that on a document system, then suddenly I have much more freedom. Let's take a look at the following model. So you should be able to see, let's just increase the size so we can see only the important stuff. You see here that we have basically three different documents. We have the blog document, which isn't really that much. We have the post document, and the post document contains the title, the blog ID, and then we have a list of comments. And this is a very important distinction because with a document database, we aren't limited to the property bug approach. We aren't limited to whatever columns we have. So we can store arbitrarily complex document inside this thing. The only limitation that we actually have is with regard to document size. The bigger the document, the harder it's going to take us longer to retrieve it from the database. And the other issue is how many updates am I going to have on a single document? Think about it. In the same way that if you have a row that is always updated by everything, it's become a hotspot, then a document that is always updated by everything will become a hotspot. So if you have a hotspot, you probably want to remove that. Another option to design a document-based system would be to do something like this. I don't actually like this. /1/comment/1. Okay, so something like this. So now the comments document is a separate document which is related via this document ID prefix, but isn't actually part of the same thing. This is very important because now I can modify a comment separately from modifying a post. On the other hand, now if I want to show the comment and the post with its comment, now I have to think about, now I have to perform more operation. I have to make an additional query to the database. So this is the first step of thinking about modeling in a document-based system. What is the transactional boundary? What are my hotspots? There is an additional issue that we have to consider, and with a relational model, which is what I'm assuming you're familiar with, the way that we design the system is to try to avoid duplication. So we are actually optimizing the system for writes, and we have a very rich query language that allows us to modify the results at read time. With a document database, the way that we usually think about stuff is actually the other way around. We have a fairly simple querying language and very simple querying options that we have along the way, but we have a very rich model when we write. So now we have to make additional choices. What sort of stuff are we going to write? Are we going to replicate information at write time to make it easier to work with information at read time? And then we have another issue, which is the notion of indexing. So in this case, specifically, I'm talking about indexing as it is implemented in RavenDB and CouchDB. And by that, I mean that an index is basically a stale view or potentially stale view of whatever you have in the actual document. So a typical example is, let's go and look at comments. And I'm going to just go right now and look at all the comments, comments where the author is, sorry, query author is Mr. Simple. And as you can see, I actually got these two comments. Now, what is very interesting is this particular bit, is still. And what is the meaning of is still? Well, this is an indication from the server, whatever the information that you're looking at is correct or not. And no, actually, it's not accurate to say correct or not. It's to say whatever this information is the latest information from the server. Now, why is this important? Because using this information, what I can do is say, okay, I may not have the absolutely up to the millisecond accurate information, but I have information that was accurate up to whatever this means, probably a few seconds past. And using this, I can now make more reasonable decisions based on whatever I'm willing to accept, potentially stale data or not. In addition to this information, I also have the ability to say, okay, given that, I can reject this information and try again for to get a new sort of information until I've caught up. Why is the database going to serve me potentially stale information? Couldn't it just, do the work that it's supposed to do and give me accurate information? It could certainly do that, but the issue here is an issue of costs. Now, let's think about most of the stuff that we're actually dealing with. There are models and there are domains where up to the millisecond accuracy is actually very, very important. The stock market is a very good example of such case. But there are tremendous numbers of cases where we don't actually care. It is acceptable to have half a second delay, even 5-minute delay. Think about every time that you put a cache in place, you're implicitly saying that yes, it is absolutely fine to get information that is out of date in this case. This is what caching means. With CouchDB and RavenDB, we have basically taken that step even further. We're saying, okay, we are willing to give you information that is out of date. It was accurate at some point in time, probably a very recent point in time, but that is a very freeing aspect of the operation, because it means that we don't actually have to do all the work up front. We can delay some of the work to a later point in time, and now this is much more this is now much allowing, sorry, let me rephrase. By being able to delay work to a later point in time, we are now able to process requests, both read and write, much more rapidly. Okay. So next step is now trying to figure out how to take all of these three issues and put them in context of how I'm going to model a system. So we know that we can model arbitrarily complex information with practically free. The data is stored as JSON documents. We know that we can query unstructured data very, very rapidly. And we know that there is a disconnect between the cost of querying and the cost of writing. So we can write very rapidly. And at the background, there is going to be work queued to actually process all of this information. So where does it put us in terms of deciding how to build a system? Well, we are going to take the blogs. The blog is a good example. And I see that, well, in a blog example, I don't really need up to the millisecond information. This is actually accurate. We don't need up to the minute information pretty much everywhere. Where we do need it, this is an incredibly rare scenario. But in the blog information, in the blog case, the information can be still. So most of my information is actually going to be, okay, give me the result from the query. And I'm going to just ignore any potential for stale data. Because of that, that means that I have the ability to make writes that are more expensive. So when I'm starting to model my information, I'm going to start to model how I'm actually going to treat working with my data storage. I'm going to say, okay, I'm going to try to make things as fast as possible, because that means that I'm going to have as few calls as possible to the database. And because we support HTTP caching, that means that even if something is fat on the wire, we're only going to have to pay the cost of actually moving that whenever that thing change. So let's take, for example, this is the RavenDB server, okay? And what I'm going to do now is actually issue a query. And now we can look at what actually happened. You can see that I issue a query, and the output of this query was actually 304. 304 is the HTTP status code, which means the information was not modified. So we actually have a query that we executed, and internally in RavenDB, we never actually bother to try to compute the query, to actually try to answer the query. We just know that this information has been changed since the last time you have seen that, and this is done. But if you care how this is done, you can look at HTTP caching and e-tags and stuff like that. But basically, this has made things much more convenient for us. We are actually storing information just by using the cache very, very intelligently by just using HTTP status codes. And let's look at what happens when you're now going to modify something. So now I'm going to modify this, and I'm going to clear out the console, and I'm going to issue the same query again. Now you can see that the information has been changed, and you can see that instead of getting the 304 that we got before, we get a 200. 200 means we have new information. By the way, the reason that we have two items here is that for some reason we get two requests from Chrome, and I never actually bothered to figure out why. So queries are cheap. Repeated queries are even cheaper, because we don't have to perform any sort of work whatsoever. And the next step is to think about modeling. Modeling, not in terms of the way that I spoke about regarding the structure of your persistent entities, but modeling in terms of what sort of queries are you going to actually query from the main storage, from the document store, and what sort of query are you going to query from the query store. So what we're doing here in this case, we're actually performing internally two queries. The first query is to actually say, okay, what are the documents that match this query? And the second query is, okay, for each of these document IDs that we just got from the database, show me the current state of the document. The important bit is that this is the current state and not the state as it was when it was indexed. So even if the information was, even if the query store is still, the actual document store where we are actually getting this information is not going to be stale. It's going to give you transactionally accurate information. And then we have the issue of MapReduce, or where all the information, MapReduce or reading information directly from the index store. So as a good example, I could do something like this. I only care for the author field, and I will get this guy. This query isn't actually being served from the document store. This is actually being served from the query store. So in this case, this information may be actually stale. When I just turn back to the previous page where we don't have a fetch, and because we don't have a fetch, we actually load the entire document, and that document has been loaded from the document store, which is transactionally safe. The database is actually going to know whatever this information is stale or not based on very simple mechanism. Whenever we save a document to the database, whatever this is creating a document or updating a document, we're actually going to increment a number. This is the document e-tag. You can see it right here. This is the 16th, this is the 10th modification to this document. So this is the 10th modification to add document on this server since I started it. And the next step here is to record at the index store what was the last document that we actually processed. Because the e-tag for a document change whenever we change something in the database, whenever we change the document, we can be sorry, I'm confusing myself here with all the stores. So let me start from scratch. Index store, where we store all the document store, where we store the actual index. What you see here, this is an index. We can actually see it probably in better shape if we actually go and look at only the index itself. So localhost/docs. Here is the index. This is a view that doesn't show us the actual metadata view. What we see here is the information that this is the result of an index query. So, and now let's see the information directly from the index store. So, I'm just waiting for everyone to catch up with what I'm showing. Okay, so we have the actual index store, and you have to understand how RavenDB works. We have the notion of an index, like this guy, and then we have the notion of a query on a set of documents. In this case, we have the notion of querying over comments, and what we want to get from the comments is the author. So you can see that we are querying for author equal to Mr. Simple. So what RavenDB does internally, it is going to scan all the comments documents, and then it's going to ask them, okay, give me your author field. And it's going to take this author field and put it in a separate store. And that is the Lucene index. We call it also the index store and a bunch of other stuff as well. And this is what you see here. This is what we actually indexed. When we actually make a query against this thing, what will happen is that we're going to query the index store, and that is going to provide us with the following information. What is the document ID, which is in this case comment/2, and if we want, we can also get the actual field that were indexed. The important idea here is that what we can actually get is either information directly from the index store, and this is a very, very cheap operation because we don't have to wait for anything. There are no transactions. There is nothing in the way that can actually bother us. Or we can do this, or we can make a query and ask the server, give me the full document. In this case, we're actually internally making two queries. The first query that you have seen, okay, give me all the documents that match author equal to Mr. Simple, in which case it gives us a list of document IDs. And the second query is for each of those documents, so we can show the full document in the result set. In both cases, the query itself is very cheap. When we load information directly from the index store, this is even cheaper. But even when we're actually just getting information from the index store and then just doing a whole bunch of query by ID, this is a very, very cheap operation. The next stage is to consider how we can utilize that. So just to recap what I'm talking about so far. Document-based modeling, designing model-based, I'm sorry. By the way, it's now 6:30 p.m. on my time, and we're working 7:30 a.m. So please excuse me if I'm going a bit of a rumble here. So document-based modeling or designing model-based document-based system means that we have to consider that what is the transactional unit of our system, and design our entities and model the interaction between different parts of the system according to that. The second part is that we have to consider that reads and writes do not have the same cost as we're used to in relational models. So in relational models, we are used to reads are generally cheaper because we have denormalized our information, and reads, especially complex reads, can be very expensive because the database have to do a lot of operations. In contrast to that, in document databases, reads are generally very, very cheap. The downside to that you may not get perfectly up to the millisecond information, but you get it very, very fast. This is about what I had for the general prepared remarks. I would like to open the floor for questions.
Yes, Oren, we have a question from Dan a little bit back. How does the database know whether the information is stale or not?
Oh yeah, okay. So the database maintains several bits of information. One of them per each index is what is the last document what is the last e-tag that this document have actually seen. And this is important. You can actually see it right here. Okay, this isn't actually the accurate one. This is also contains some other issue, but this is the last e-tag that this index have actually worked on. And the second stage of that is that because we can compare the index e-tag to the last updated e-tag, we can, by a very quick comparisons of two numbers, determine whatever two items, whatever this index have actually caught up with the last update to the database. And there is another issue here with MapReduce indexes, and in this case, this is a bit more complicated because this is a two-stage process. We are still using e-tags, but we're also using something called the task queue, in which case we are basically asking the database if there are still any more reduced operation to perform. But the easiest way to think about it is that we basically just compare two numbers. What is the last document update that you have indexed, and what is the last index update overall? And if they are the same, then obviously we have found our match. If they are not the same, then we have to assume that the index is 10. One thing that we have to remember is that in a system where you have lots of updates, it is entirely possible that the index will never it's entirely possible that the index will always be stale. So if we keep, for example, And I'm just throwing some number. If it takes 1 minute to update the index, it takes some milliseconds, obviously. But if it takes 1 minute to update the index, and we have a new document or a document update coming every half a minute, that index is never going to catch up. That is perfectly all right with us, because what it means is that we don't really care. We don't really care because we have the index timestamp. We can say, you know what, I don't really care if the index is still or not. All I want to know is that this is accurate up to the last 5 seconds, up to the last 5 minutes, or 3 hours, whatever this is. Okay. Next question, please.
From Brian, when a document contains a reference to another root aggregate document, how do you only include the pertinent data from the reference document? For example, only copying over 2 properties out of a possible 10 properties.
So that is actually, so here's an example of a root aggregate that refers to a separate root aggregate. So we have the idea of a post, in this case, post number 1, which refers to the blog, which is blog number 1. Now, there are actually 2 different ways of doing that. One of them is what we like to call a denormalized reference. And a denormalized reference basically says, okay, I'm going to store inside the post the blog ID and the blog name. And there's actually some nice code that shows how to do it very easily inside the RavenDB website. You can search for denormalized references, and I can probably find it faster if I just go here. And so there's probably somewhere I can put notes, but this is basically the URL, ravendb.net/faq/denormalized-references, and you can see it there. But for the most part, this is one option of doing that, but this is not an option that I really like. We can also do this. So this is actually a query for give me the document whose name is post number 1. It's semantically the same as the URL that I had before, doc/post/1. The nice thing about it is that now I can do something like this. Also include the blog ID. And the nice thing about this is, let's take a look at what the result set of doing this now does. So you can see that we actually have 2 parts for the reply. We have the idea of a result, and you see that we have now the result for blog number 1. Sorry, we have the result for the 4th post, but we also have the idea of includes. The includes is a side channel. What do you mean by a side channel? It means that this is not the result for the query that you just issued, but this is probably something that you've indicated you're interested in based on the information that we got from your query. So you see that what we have here is blog number 1. So in a single query to the database, we're actually able to load both the primary document and an associated information. The RavenDB client API has built-in support for doing just that, which means that you can just indicate, okay, I want the blog, and I want the post, and I also want its blog, and we just do that for you and save you all the bother with trying to do denormalized references and stuff like that. The caveat here is that this will only work as long as you're running on a single server. I know that I say that I don't want to talk about scaling issues here, but this is somewhat important, because when you're talking about, okay, I want to run on multiple servers, then I cannot do an include across server boundaries. For the most part, what we have found is that the way that you sharded information in the first place, the way that you split information among multiple servers, it means that these sort of things, these sorts of references are going to always be on the same server. It is very rare that you have references that cross shards boundaries, just because the locality cost becomes very prohibitive. And I hope this answers the questions. Let's see the next one.
The next one, you talked about document DBs being fast, but not necessarily up to the second accurate. Is this what they mean when they say eventually consistent? And is this something you can control in Raven?
Yes and no. When you're talking about eventually consistent data stores, we usually talk about something that is even more loose than what we have with RavenDB. So eventually consistent information means something very similar. If we stop accepting updates, at some point in time, all parts of the system will have the same information. What it means is that I have some view of the information, but it may be an old view. That is what it means to be eventually inconsistent, because if the information stop updating, eventually we have whatever is the last view. With RavenDB, we actually have always accurate view on the document itself. So when you ask me for a document, you always get the read committed latest version. It is possible that the document is currently being modified by another transaction, and so you won't see the uncommitted changes. You will, by the way, see that it's right now being updated. That's a different issue. So for documents, we always give you the up to the millisecond latest information, and we do that in a transactionally safe manner. For indexes, for queries, we're saying yes, we will be eventually consistent. The assumption here is that for the most part, just being able to query and get and the document data is transactionally safe, you can live with the query itself being somewhat still. And this is even in the cases where you really, really care about how fresh is your data. So to summarize, the documents are always accurate. The indexes may lag behind a bit, and you could call it you could call it eventually consistent. It just depend on what you actually consider the eventual. The documents are always consistent. The indexes will be eventually consistent. And let's look at the next one.
Do we ever use join operations when querying?
Tough question. The quick answer is no. The longer answer is that yes, and the really complex answer is that you should avoid it, but it is possible. The basic idea is that yes, we can actually create. I'm just going to write. Okay, let me just do some work to explain how query actually work with Raven. So let's go to localhost. And right now, what we did here is we just wrote some queries and asked RavenDB to just implement them on the fly. And RavenDB can just do that. If you ask it, okay, give me all the user whose name is Ayende, it will go and do that for you. It supports ad hoc queries. This is, by the way, something that is most people consider to be just of course, but this is actually something very, very complicated to do in a schema-free data store. So I don't know what your schema is. I have no way of actually building on this data structure to do that. So what I'm actually going and doing behind the scenes is doing this. I'm going to write a link query, and this link query is going to operate over all the indexes, over all the documents who's all the comment documents, sorry, and I'm going to output the document, the comment auto out of that. And that gives me a consistent view, something that I can actually work with in much easier manner. I'm going to take this thing, I'm going to shove it into an index structure, and then I'm able to actually perform queries on that. Now, taking that to the next step, I can also do something like this. From, let's say, from from post in docs.posts, select new. And this is the map. This is the index creation. Title, post.publish date, something like that. Now, I can do this very, very easily, and this creates an index that allows me to search by the title and the publish date. The second stage, we call it transform results, also live projections. And this means that, okay, now that I've found the set of documents that match the query, I can run transformations on them. So this looks something like this. From result in results, let's say that I want to say something like select, let blog equal database dot load result dot blog ID, select new, blog equal blog, post equal result. What we have done here is basically create a join between the blog, between the post and the blog. And we've done it in a very efficient manner. We don't have to worry about stuff like Cartesian products. We don't have to worry about a explosion of the result because of that. This is because this also happened very late in the game. This doesn't affect the paging scenarios that you're working with. So the paging is applied before this happens, and then you can actually only do this join on whatever information you have left. Just to give you some even nicer options, we can also do this on collections. So we can say stuff like, I don't know, tags equal results dot tag IDs dot select database. Oh hell, I can just do this. Yeah, I can do this. Something like this. Now, by the way, this is a very bad design for a document database, but bear with me. This means that, okay, here is the tag IDs. Let's go and load all the tag IDs that we have and put them into tags. So this is now a three-way join. Actually, this would be in a database a four-way join because we have the association table. And if you have any sort of real data sizes in the database, this would cause a huge Cartesian product. But what we have here is a very, very efficient operation. We only load the information that we need. So yes, you can do joins with RavenDB. I wouldn't necessarily recommend it. They are probably want to think about the way that you design your information, the way that you design your system. But this is certainly possible. This is certainly something that we see a lot of users doing. Okay. Next question, please.
Great. From Michael. Can you discuss document ID strategies? They appear to be string values. Can you use your own GUID as an ID in your documents?
Yes. So usually I like to think, okay, let's do some. So right now we have auto-generated. And I'm going to say question, good. And let's see what happens now. Okay, so as you see, we have created a new document, and the document ID is some sort of GUID. Now, I'm going to wait until everyone sees this screen, and for the main point, what I want you to think about is what is the properties of a GUID that make it so valuable. So while you're thinking about that, I'm going to switch tabs. And now I want you to tell me what was the ID of the newly created document. And I'm going to bet that 96 of you are not going to be able to remember what that ID was. And this is because GUIDs as identifiers are horribly broken from one important perspective. They are utterly and completely inhuman readable. That means that if you ever had to read a GUID over the phone, or you ever had to try to recall, wait, have I ever seen this ID before? You know that GUIDs are very, very user unfriendly. By default, RavenDB has three options for actually four options for naming your for the document ID generation. The fourth option is just tell me what you want, and I will do it. All the document IDs are strings. The client API can handle it if you want to use an ID, if you want to use an int identifier or a long identifier or a GUID identifier, it can just handle it just fine. But internally, the document IDs are actually strings. Now, you can go to RavenDB and tell it something like this. This is the document ID, user/ayende. This is probably something that relates, to the document, to the meaning of the document. So in this a document like that would be very meaningful. We know what the name of the document is. And this is also the username. Another option that we have is a GUID. So if we just let RavenDB decide what the document is, it is going to just go ahead and do that. Another option is to call when we create a document, to call it foo_. Now, RavenDB does not allow you to end a document ID with a slash, but it will accept this query. It will accept this save, and what it will do, it will treat it as a request to create an identity. So now we have foo_1. If we try to create a new document and we call it with foo_, what will happen is that, I'm just waiting for everyone to catch up. So we try to create a new document and name it foo_, and what we will see is that, oh yeah, I call it foo_bar and foo_bars. Let me try again. Foo_bar bars /1, sorry, foo_bar with just the slash, save, and now you can see how it goes. So when we end a document ID with a slash, RavenDB will use identity semantics and basically just increment over whatever was the last one that we used. And the final one is when there is a identifier generation strategy called HILO, which basically means that we can generate identifier for documents by going to the database only once every 1,000 documents or so. So it is more efficient in terms of how often do I have to go to the database. So the basic idea is that we have four options: either just GUIDs, use assigned, such as user ayende. We can use basically the identity, so foo_bar/1, foo_bar/2, or we can use high-low. High-low basically just same as identity, but we don't have to go to the database as often. The main criteria for naming a document for is that I want it to be A, human readable, and somehow meaningful. So if I have a user and the username is the absolute main thing about this user, I probably want to reflect that thing in the document ID because it makes it easier to think and discuss and talk about those sort of things. A typical example with a post, if the slug is what I care about most in a document, then I will name the document. If the slug, the URL of the post is the most important thing about the post, then the document ID for the post would be that slug, that URL. In many cases, I don't actually care about what is the specific document ID, but I do care for it to be human readable. In those cases, I would usually use high-low, and in some cases, I will use identity. The main advantage here is that even if I have some relatively large number, well, numbers are very, very easy to read, very, very easy to work with. I can deal with them very, very nicely. And that is it for naming IDs. Next question, please.
Next question. Is there a limit to the number of objects or sub-objects that can be serialized in a single operation? Also, is it possible to perform object locks on the server?
Okay, so the fourth question is regarding the maximum data sizes. So technically, we are limited not by the number of objects, by the size of the objects. RavenDB is currently limited and will be limited for the foreseeable future to a 16 terabyte size, for 16 terabyte maximum size of the entire database. Now, it's probably going to take another year or two for 16 terabyte disk to come out. So I'm not really worried about that. And for the most part, if you have that amount of information, you want to share it to multiple servers anyway. There is a cost associated with big documents. I'm talking about multiple megabyte documents. We are actually working on elevating that cost. Ideally, we want to make there is still going to be a size and performance difference as size grows, but we want to make it not orders of magnitude, but some minimal percentage. But for the most part, I would say that unless you get to the multi-megabyte range, you don't really care about that. And just to give you some ideas, even in the multi-megabyte range, we're talking about hundreds of milliseconds, not multiple seconds. In addition to that, there was the other part of the question, which I managed to forget. What was that?
Part of the question was, is it possible to perform object locks on the server?
Yes, so object lock are possible, and they are possible by utilizing the internal transaction for RavenDB. So RavenDB has multiple levels of transaction. You can have a transaction for a single document update, for a set of document updates, for a set of requests, or even for a set of requests spanning multiple servers. The last one is not really recommended. Locking an object can be done by actually starting a transaction and modifying the document in that transaction. Basically, a no-op modification, which would result in the document being marked as, okay, I'm currently being modified in a transaction. Other users may still look at this information, but they will not be able to modify it. This is something that would probably recommend against for most scenarios. But yes, this is certainly something that you can do. There is no way of, however, of doing something like, okay, I don't want anyone else to read my data. Well, there is a way if that someone else is cooperating with you and say, I don't want to see data that someone else is currently, maybe currently changing, but that's about it.
Okay, so let's see. Can one update multiple documents automatically?
Yes. So what you're talking about is set-based operations. And here we have to consider several features with RavenDB that combine to make this feature. The first feature is that we have the ability, again, when we're talking about big documents, to send just the update to the document in question. So I can actually say something like, okay, given this document, and let's say that posts have a content field that may be, hundreds of kilobytes in size. So all I want to do is just to update the title from one thing to another. I can actually say to RavenDB, okay, in document post number 1, update the property title to this new value. So this is called patches. The second option is that RavenDB has the option of performing some sort of a query. So basically, given this query, return me the set of document IDs that match this query. Why is this important? Because we can combine both of them to say, okay, given this query, perform the following change on the result of this query. This is basically an update statement with a where clause. Now, the reason this is important is that this is still subject to the staleness concerns. So you have the ability to say, okay, I'm going to reject making any modification if the result of the query is stale. So yes, you can do that. You have to consider whatever changing with staleness is appropriate or not. And you have to consider whatever you want to reject the staleness, or you want to update everything that has been returned by the query, and maybe retry the query again at a later point in time.
Can we choose settings about consistency and availability preference?
Yes, when you're talking about multiple servers at the same time. So consistency. So the basic idea is that we don't make such a decision in RavenDB itself. So you can choose RavenDB to run in mode that is fully consistent, and you can choose RavenDB to run in mode that is fully available. The basic idea is that we allow you to run in a sharded environment. So in a sharded environment, you can say, okay, I'm going to split my data to as many servers as possible to increase parallelism. In a replicated environment, you're going to say, okay, I'm going to replicate my data to as many databases as possible to increase safety. And finally, you have the notion of what happened when a node goes down. So in a replicated environment, when a node goes down, we will silently fail over to the secondary node. And at that point, you have the choice, okay, am I going to accept writes to a node when the master node for this information is down? Or am I going to accept reads but reject writes? And the second option is whatever, when I'm running on a sharded system, what do I do then? So there are lots of balances lots of options that you can play with to fit your own scenarios. And it can actually get pretty complicated because you have lots of knobs to turn. The usual recommendation is that you run with a replicated environment, but you will reject writes on a failover. So if the master node for some piece of data has failed, you will not allow writes to this information, but you will still allow reads. And in order to ensure a scale out, you generally run in sharded servers, where each sharded server is also replicated.
Let's see. I listened to one podcast about RavenDB that RavenDB creates indexes on the fly, and if a query occurs sufficiently often, it persists them. What happens if the queries are very different?
then it actually depend a lot on a bunch of stuff. The trivial example is what happens if you have a query that comes once every day. So it comes once every day. We compute some sort of an answer to that question, and then we give that answer back to you. And after a while, well, no one cares about this query, so going to stop updating the index that serves this query. Next day, same things happen. We compute the information from scratch, and you go away, and then we drop after a while. But this is assuming that this query is actually being very, very unique. RavenDB actually have a query optimizer that is able to consider several queries and say, okay, what sort of query have we? So let me actually show you the query optimizer. So I'm now going to execute this query. This is interesting. Don't I have a Mr. Simple anymore? One second, let's look at the actual data. Okay, I'm now going to want to make a search for, no, yes. I think I made some sort of an error when editing this guy. Let me just delete this. So let's look at this one. So as you see, we have this thing. This is the index that was automatically created for us when we issue this query. Now, if I'm going to make a second query, and this time I'm going to ask for Mr. Complex, what you will see is that we reuse the same query. But let's go here and define the following index. Comments by name and date. And from comment in docs.comments, select new comments.name, comment.date, sorry, by auto. So this is, so now we are going to create the following index. And we're going to save this. And now we're going to issue the same query. Oh yeah, we already have this one. So let's delete this one. And now we have deleted the temporary query, and we issue a new query. Now, what you can see in the index name here is that what we actually, the actual query optimizer didn't really have to create a new query for us. It was smart enough to figure out that, hey, you want to query on auto. I already know what auto is. I have no problem with just figuring that one out. So what I was able to do is to actually reuse an existing index. And in the future, we will be able to take multiple temporary index and aggregate them, so we have fewer indexes on the same sort of entity, on the same entity type. So this is the basic idea. So we start from trying to figure out if there is an index that matches what we want to use. And in this case, the query optimizer is able to use that. If it's not able to use that, it's going to create a new index. And if that index is going to be used a lot, that index is going to be escalated to be a permanent index. So that is the 10,000-foot view of how the ad hoc querying with Raven works. And yeah, go ahead.
What is the underlying storage of RavenDB?
So the underlying storage is actually composed of two options, which is controlled by a configuration option. The recommended storage engine is ECENT, which is the backend store for Active Directory, for Exchange. So it's a very robust storage engine, very fast. It is something that we've been using for several years and it's been very successful so far. And the other option is Munin, Raven.Munin, and this is a fully managed implementation that is mostly meant for small-scale, lightweight, with no requirement to run on, no requirement to touch unmanaged code. The Munin storage is very, very fast, but it has much greater memory requirement than the Essent option. And the Munin, well, obviously Munin is several months old. It haven't had the option of being battle tested. It haven't have the hundreds of man years that, hundreds or maybe thousands or more of man years that are spent in Essent. And it hasn't been as thoroughly tested as the Essent storage. Currently, we use Munin for the unstable storage, and for stable storage and production deployment, we recommend on using Essent.
Let's see. Can you talk about deployment? How would you deploy RavenDB in a hosted environment?
I assume that we're talking about something like GoDaddy or Simple ASP or something like that. So we have people hosting their stuff there. We actually have two deployment models for them. One of them is as a child virtual application, so a child virtual directory, which basically means that RavenDB runs inside IIS as a standard web application, and your application can just access that information over HTTP on the same server. The second option is actually to embed the RavenDB application inside your application. So RavenDB is going to run as a component inside your app domain. You won't use HTTP to access the server. You just use direct calls to the server itself. That's it.
Okay. Can you store documents like PDFs or TIFFs?
Yes, in the sense that this is possible, but you wouldn't store them in the sense that this is a document. When we talk about a document in RavenDB, we're actually talking about, I'm sorry, by the way, I'm being attacked by two very, very affectionate dogs right now. Yeah, so they've managed to open the door for my office, and they're currently very insistent and demanding attention. So I'm sorry if I'm sounding a bit scatterminded right now. So documents in RavenDB are actually JSON documents. They have structure that the server can understand. And documents such as TIFF or PDF are actually binary data that RavenDB don't really have any information on how to deal with. You cannot store binary data in RavenDB. We call them attachment, but this is probably not what you meant by storing documents.
Let's see. I don't know. We'll see. He'll get back to us.
I'm still there. Can you hear me?
Mm-hmm.
Okay. So are there any further questions?
There are a lot of questions. I don't know if we're going to be able to get to all of them.
Okay.
Warren, you have actually quite a few in here. Let's see. I'm trying to see. Are the transform results queries executed from the client resulting in multiple calls to the server or on the server?
No. Transform results are executed on the server. They require no extra work on the part of the client. And the client just basically get the process data normally. This is a very, very efficient manner to do all sorts of stuff, including the live projection stuff, which if you wanted to do it on the client, well, you didn't need this sort of thing. It also happened on the server and a very, very efficient way of doing stuff.
Let's see. Is there link support to use the RavenDB API?
Yes. That's That's about it. Yes, it's a
That's
post link.
good. I like that. It's a good short answer. Let's see. What kind of security or authorization features are in Raven? Can I block on root, object, or property levels?
Okay. It actually depends on server levels. You have authorization at the server level. So you will not be able to access the server unless you have the appropriate login. The second part is whatever you can block access for a specific document. And the answer to that is yes. And it actually depends on how you want to do that. So RavenDB comes with an authorization bundle. Bundles are ways of extending RavenDB. And that authorization bundle allows you to say, okay, here are the set of rules that based on that you will be able to say yay or nay for the operation. You can also, but this is over the whole document. You're also free to write your own custom logic for deciding whatever user can or cannot access a document. And what is more, you're able to write a bundle, an extension to RavenDB, which will, based on whatever logic you have, block access to certain parts of the document. In fact, we have customers doing just that. Based on whoever the user is and some information in the data, in the documents, they will block at the server level access to certain parts of the document. They will literally remove it from the document. So if you are you and you access your document, you will be able to see your, I don't know, social security number. But if you're someone else and you access this information, that information will be removed at the database level. So this is a bit like having column level security. And this is, again, done in a very, very easy way to implement and very efficient manner to execute.
Let's see. How do you handle things like schema updates and data migration for a live database?
Okay. Schema migrations are an interesting bit because there is no schema. The database can handle a document in any shape or form that you like. What usually happens is that if you remove a property, well, next time that you update this document, it will just be updated to not have this property. If you added a property, then it will be set to the default value, and after a while, and you have to fill that value somehow, and that is the basic of how to do that. A rename operation is basically a removal and an addition, and by default, RavenDB will not allow you to do that. I mean, RavenDB will just consider that you remove the old property, you added a new property, it doesn't give you any sort of options to do that. What it can do, in conjunction with the ability to handle a set-based update, you can do stuff like that. You can say, okay, I want to rename all the operation in, I want to rename some property from A to B on all documents. And it can do that on a live production server. My general recommendation is to actually, because the reason that you actually care about the schema is for the code. And I would suggest still going with the, go away, girl. I'm sorry, that's the dog which decided that I'm a mountain and I should be climbed on. I'm going to post some pictures of them. Actually, I'm going to post pictures of them right now to Facebook so everyone can look at who is attacking.
What's attacking you?
Yeah. So I was talking about, what was I talking about? I was talking about something regarding, no, I already talked about security. And
yes.
I was talking about something else, but I don't recall what it was. Let's see. No idea.
Schema, or we already did that.
Oh, yeah, schema update. Yeah, no. So the schema update, so the basic idea is that when you're actually talking, about modifying the schema, the part that you usually care about is not the this is not the actual database that you care about, at least not with something like RavenDB. What you really care about is the updates to the code that require to support the new modification. So those changes means that you have to have your code prepared to handle the new version of the data, and maybe also the old version of the data if it takes time to update it. So basically, just as long as you consider the code as the most important thing there, I don't think that you should have a problem. Just make sure that the code is able to handle the old version of the data, and you're done.
Awesome. We have time for a few more questions. Let's see, from Brian. When using command query responsibility segregation, since the querying in RavenDB is essentially separated from the writing, should I create separate databases for reading and writing?
No, the actual storage is different. You can consider them to be two different storage implementation. RavenDB is actually, you can consider RavenDB to be a CQRS implementation from the get-go. We actually have an implementation that shows a very nice way of defining your event sourcing logic as RavenDB index, and RavenDB will just take care of all the grunt work there for you.
All right, let's see. Are the transform results queries executed from the client resulting in, oh, I think we did this one, in multiple calls? Sorry, we did that one. What are some strategies for working with data replication and data duplication, for example, in an SOA where pieces of data are shared among multiple services?
Okay, RavenDB supports out-of-the-box replication, so you can literally just say, okay, I want these databases, I want this database to be replicated to this second database. And the second option, you can also say, okay, I want to replicate this information not to a different RavenDB database, but to an actual different relational database. So you have these two options. Regarding SLAs, usually I would handle that by replicating information and then sharding among the replication, probably with a bias toward one of them toward the master for writes, but that is more or less how we design that, with the caveat that it's very easy to design stuff like that when you just throw in a sentence or two in the air.
Is it possible to control the old value if I'm updating, something like value change between select update?
Yes, so you're talking about optimistic concurrency, and in that case you can say, okay, only update this document if it matches the previously known state. And or you can also do that when you're using patches. You can actually do a comparison on the actual value. So only update the property title to new title if it's equal to old title.
How different is a document model compared to our object UML class DDD diagram? Will we need some object mapper and conversions magic?
Generally not, with the small caveat that when we're talking about here is that objects by their very nature are very different than most storage model provide. So a typical example would be that when we're talking about objects, then we're talking about something that where the cost of traversing the association is very, very cheap. But in most databases, in most data source technology, the cost of traversing association is non-zero. As a result of that, what we are looking at can be that, yes, we want to model our stuff in a certain way, but at the same time, we also want to be able to, how do I say that? But at the same time, we also want to take into account what are the costs associated with the sort of model that we propose. For the most part, I would say that the DDD model, as outlined in the Blue Book, is very, very similar to the way that I would design stuff to RavenDB. In fact, the way, intentionally by the way, the way that the RavenDB client API works is by straightforward serialization of the information from your object graph to the RavenDB document, with the design consideration that this is how you want to design your entities, with the notion of root aggregates and no direct references between entities except as the idea of another root aggregate.
All right, let's see. Fully understanding that this is not the purpose of RavenDB, would you consider it possible to write reports from its data, and how?
My quick answer would be no. The longer answer would be that it can handle reports. It can actually handle reports very nicely. The problem is what you consider a report. If you want to just shove it into some report editing tool, like a grid that allows you to do random grouping and sorting and all sorts of stuff like that, well, that isn't going to work. That isn't going to work because RavenDB expects that your information will be with a certain, your information will be known at some point in time. So yes, it can support ad hoc queries, but they are still somewhat expensive. So what we want to be able to do is to understand upfront what sort of query we have. Even RavenDB ad hoc queries will eventually become standard queries on well-known indexes. They are self-optimized options, but they're still just that. So if you have well-known queries, well-known, and you just want to query on those, yes, you can do reporting. You can do reporting very nicely. Typical example, if you want to do statistics in an application, so how many posts have been posted, how many comments for this post, stuff like that, this is very possible. But if you want like real live user reporting, you probably should use an OLAP database.
Awesome. They said that's what they wanted to know. So there you go.
Okay, wonderful.
Let's see. You may have already answered this, but how appropriate is RavenDB for compiling statistical data? For example, number of posts with a thumbs up rating for a given author. Very, very good.
So you can do something like that very, very easily by defining a MapReduce index. And a MapReduce index is something that sounds very, very scary, but a MapReduce index is quite simple. A MapReduce index is basically just two very simple link query. And let me see if I can find that so I can look at that. So we're talking about a thumbs. So what was the server again? Thumbs up for what?
Thumbs up for a given author. Yeah.
Okay. So this is the index name. Now we're going to doc from post in docs.posts. From both in post.loads. So what we are doing right now is just creating a simple inquiry, and that simple inquiry is going to run over all the post document, and it's going to inspect all of their votes. And for each vote, we are going to emit the following information. Who was the post author, whatever the vote was positive or negative, and the count of 1. This is the map part of the operation. Now we're going to write the reduce part of the operation. So now let's take a look at this now. What we have here are two link queries. The first one basically output one element per each vote with the count equal to 1. The second query is a simple aggregation by the author and whatever the result was positive or negative. And based on that, what we can do is aggregate that and then give you a summary for all of them. Let's be sure of post/ authors by votes. And let's just take this query and create some indexes that will support it. So let's go to posts. And we're going to say that author is IND, votes positive, true. So this is So this is one post. Let's create a second post. This time is also by IND, but now both of them are false. Here is post number 3. And now what we want to do now is to query indexes/post, and I don't remember the So now you see what actually happened. Now we have aggregation of by the author and the whatever this is positive or negative across everything. So this is very, very easy to do. This has 0 cost. Just to give you an idea, now I'm going to execute this again. And you can see that for the most part, this returns a 3 or 4. This information doesn't change that often. That means that we can take huge advantage of HTTP caching and being able to serve directly from the index store. So this is a highly performant operation. And okay. I think that we can take
one
do we
more
have
question,
time for
I think.
Yes.
Let's see. According to you, in what scenario are document DBs or NoSQL solution are more applicable than an RDBMS solution?
I would say that for OLTP scenarios, for most OLTP scenarios, the notion that you can just use a transactional boundary that is very, very flexible, such as a document, make things much, much easier to work with. It makes things a lot easier to think about, to reason about. It makes a whole lot of sense. Typical example, let's consider the order. Well, an order line is a part of an order. You cannot touch an order line without touching an order. With a relational database, you have to jump through a lot of hoops, use constant locking, maybe have multiple paths to the same place. just in order to ensure that very simple truth. But with a document database, the order is the document, and suddenly it's become much, much easier to work with. So I would say that most OLTP scenarios, again, I'm biased because I'm writing one, so it's very easy for me to think in a document-centric fashion. But I would say that for the most part, I would say a lot of my work would be a lot of the OLTP, a lot of the business, business level development can just use documents, just throw everything into the root aggregate, and it become much easier to work with.
Okay, great. There were some questions left, but we do save the questions log, Oren, and we'll send that to you, and you can take a look and see what we didn't get to. But thank you so much. It was a really cool webinar.
You're welcome. It was fun.
And everybody, just so you know, we have 2 more webinars today. In half an hour at 10 a.m. Pacific Standard Time, using DevExpress controls to build a ribbon UI and dockable panels in Silverlight with our Silverlight evangelist, Emil Misrobian. And at 12 p.m., Visual Studio 2010 testing with Microsoft's Steve Lang. And tomorrow, ASP.NET MVC3 with DevExpress extensions with ASP.NET evangelist Mohul Harry. So we have 3 more webinars this week. If you would like to register for them, just visit us at devexpress.com/webinars. And again, if you missed anything from this webinar, if you joined us late or you want to review any of our previous webinars, you can watch them all on our DevExpress channel at tv.devexpress.com. And this one will be posted probably either later this afternoon or by tomorrow morning. Again, thank you so much, Oren. Thank you all for being here, and thanks for choosing DevExpress.